Welcome to The Explainer. Today, we are diving deep and pulling back the curtain on the hidden architecture that makes the very best AI coding agents, well, feel like actual magic.
You ever have this happen? You give the same prompt to two different AI tools. One gives you genius code, the other just spits out a complete mess. It's a frustration I think every single developer knows. And the answer, as it turns out, isn't just about what language model is running under the hood.
The real secret, the thing that makes a huge difference, lies in what the experts are calling the proprietary chassis. This is the advanced engineering framework built around the AI model. That's the key. Okay, so what is this chassis really? Let's dive in and look at the blueprint that separates a simple tool from an autonomous partner.
Okay, so here's the best way to think about it. The AI model itself, like GPT or Opus, that's the engine. It's super powerful, for sure, but it's not the whole car, right? The chassis, that's everything else. It's the high-performance vehicle built around that engine. We're talking the navigation system, the drivetrain, even the safety features. It's what actually lets you use the engine's power effectively.
So this whole chassis thing is really built on three key pillars. First, it has to understand your code base, like with a perfect memory. Second, it has to think by exploring a bunch of different futures to find the best solution. And finally, it has to act like an automated, coordinated team. We're going to break down all three, starting with how these agents get that flawless understanding of your code.
All right, pillar one, the perfect code memory. See, the most elite agents, they don't just search your code in the traditional sense, they map it out with absolute surgical precision.
So for a while, the standard approach was what's called vector RAG. And it's pretty good at finding things that are semantically similar. But if you ask it to do something really tricky, like trace a complex dependency, it can get lost. That's where the top agents are doing something way different. They're using what's called the Deterministic Knowledge Base, or a DKB. They actually build a precise map of your code using abstract syntax trees, or ASTs. It's like they're reading the code's architectural blueprint, not just its words.
And just look at the difference here. The research on this is kind of staggering. Building one of these deterministic graphs, it took about 3 seconds, with perfect correctness. Trying to get an LLM to just guess the structure? Over 200 seconds. It cost 45 times more, and it still got things wrong. I mean, when it comes to reliability, the choice is pretty obvious. But what's really clever is that these systems don't just ditch the old methods completely. No, they build a hybrid search. They use something fast, like BM25, for finding exact stuff, like a function name or an error code. Then they use vector search for the bigger conceptual questions, like how does our authentication work? And then, this is the cool part, they merge both sets of results using something called reciprocal rank fusion. You literally get the best of both worlds, precision and context.
Okay, so the agent understands the code perfectly. Now what? How does it think? This is our second pillar, and honestly, this is where things get really wild. The best agents are basically exploring multiple futures, like parallel universes of code, all at the same time.
A lot of this comes from a framework out of MIT called Encompass, and the big idea here was to separate the what from the how. So you have the agent's actual workflow, but then you have the search strategy for finding the best path through that workflow. It's a total game changer. It's based on this pretty wild concept called probabilistic angelic non-determinism. Just stick with me here. The idea is that the agent acts as if an angel is just guiding it to the perfect outcome. But in the background, the chassis is doing all the hard work, exploring every single possible path, all the dead ends, to find the one that actually works. It's pretty amazing.
So here's what's actually happening. The agent gets to an unreliable step, right? Like an LLM call. It hits a branch point. At that moment, it basically clones itself to try out a bunch of different solutions in parallel. Each of those paths gets scored. The bad ones, they get thrown out immediately. The system automatically backtracks from all the failures, so by the time it gets to you, all you see is the one successful path. It's like a choose-your-own-adventure story where it already explored all the bad endings for you.
Okay, that brings us to our third and final pillar. And this one might be the biggest secret of all. It's not about having one single super-intelligent agent. It's about orchestrating an entire automated team of them. The way the elite platforms do it is with a multi-agent hierarchy. You have a planner, usually a big, high-reasoning model, whose whole job is to break the task down into a solid JSON plan. Then you have the executor. This is a high-throughput model that just gets the work done, writes the code. And then you have a critic. This is a high-logic model that validates the work, looks for bugs, and, this is crucial, it can veto the changes if they're not good enough.
So how does this whole team talk to each other? They use a standard called the Agent Client Protocol, or ACP. The best analogy for developers is probably the Language Server Protocol, LSP. Think of ACP as LSP for agents. It's what allows the editor and the AI to have this clear, two-way conversation.
And this is what ACP gives you, the user. You get to see in real time what the agent is reading and editing. You can see multi-file diff views to review everything at once, and most importantly, you have the power to jump in and redirect the agent anytime you want. It completely gets rid of the black box feeling. It's more like true pair programming.
So, let's step back for a second. When you put all of this stuff together, the perfect memory, the thinking in multiple futures, the automated team, it all starts to fundamentally change what it even means to be a developer.
We're moving beyond a world where your main job is just writing lines of code.
Instead, developers are becoming architects of these autonomous systems. Your job is to design the goals and direct the agents that can handle all the messy implementation details for you.
And that's really what it all boils down to. Are you just prompting a simple assistant, or are you directing a sophisticated agent? Understanding what's inside that chassis, all the stuff happening beyond the prompt, that is the absolute key to unlocking what these tools can really do. And, maybe more importantly, unlocking your own potential in this new era of software development.